Hope you've had a lovely day. Today our topic of discussion is financial mathematics. This is a topic you have learned since grade 9, if you remember, grade 10, 11 and 12. So with financial mathematics, we deal with financial growth, where we deal with the simple interest and the compound interest, and the formula for simple interest is the first formula at the top of the document, followed by compound interest, where P represents the present value of the investment or the loan, A being the accumulated amount or the future value, N is the time period, R is the interest rate as a percentage. Then the graphical relationship between simple and compound interest. Compound interest is represented by a curve graphically, and simple interest is a straight line. Then we have financial decay or financial depreciation. Of course, in reality, when you buy a property, for example a car, the more you use it, it loses value, so it depreciates, and by the time you sell it, you won't get the same amount of money as what you use when you were buying the car. And the graphical relationship between linear and the reducing balance depreciation is represented by the graph. Hope you can see the graph on your screen. So the main focus for this evening is to take you through solving activities on financial mathematics. So question 1 states that Robin invests 30,000 rands at 16% per annum compounded quarterly for a period of 15 years. 1.1 Convert the nominal rate of 16% per annum compounded quarterly to the equivalent effective rate. So you need to know your formula. So the formula is 1 plus I effective equals brackets 1 plus I m over m to the power of m. So where m represents the nominal period. So in this case, the nominal period is the quarters, and we know that in a year there are 4 quarters. So with substitution, your 1 plus I effective will equal to brackets 1 plus your 16%, which is 16 divided by 100, which gives you 0.16 divided by 4, because you have 4 quarters in a year, to the power of 4. So making your I effective the subject of the formula, this gives you brackets 1 plus 0.16 over 4 to the power of 4 minus the 1. So you punch that value into your calculator, you get 0.1699, but then you have to multiply it by 100, which finally gives you the effective interest rate as 16.99%. Let's go to question 1.2. Now use the annual effective rate to calculate the future value of the investment after 15 years. So it's compound interest. So use the formula A equals P brackets 1 plus I to the power n. The original amount is 30,000 brackets 1 plus. The question tells us to use the annual effective rate, the one we have just calculated, 16.99%. You divide it by 100, you get 0.1699 to the power 15. So candidate, you punch that into your calculator, you get 315,756 rands with 55 cents. Hope you are following. Let's go to question number 2. Allow me to change the color of the pen. Mpo deposits 80,000 rands into a savings account, paying 13% per annum, compounded monthly. After 5 years, the interest rate increases by 4%. This statement hereby is a trick in a question. 3 years later, the interest rate decreases by 1%. Calculate the value of high investment after 10 years. So it's the single investment of 80,000, but now it is experiencing 3 different interest rates. First, the 13%. Later, the 13% increases by 4, which makes that 17%. Then after, it decreases by 1%. So from 17, that gives us 16%. So we can use a timeline so that we get the actual picture of what is happening here with a timeline. So at the beginning, which is T0, 80,000 rands was invested into the account, and our investment lasts for 10 years until T10. So the 80,000 is supposed to be in this account until the end of 10 years. But what is happening? There is a change in the interest rates. The 13% per annum compounded monthly after 5 years. So that means for the first 5 years, the interest earned is 13%, meaning 13 divided by 100. And that means our N in this case would be 5 times 12, because the interest is 13% per annum compounded monthly. Then what happened after the 5 years? The interest rate increases by 4%. 3 years later, so 3 years later from the first 5 years, we find ourselves at T8. So between T5 and T8, the interest rate is increased by 4%, which gives us the 17%. So we have 0.17%, but of course compounded monthly. So we are dealing with N. These are 3 years times 12. Then thereafter, it decreased by 1%. So between T8 and T10, our I is 16%, which is 16 divided by 100, and our N would be the 2 years times 12. Okay, so with the formula A equal to P brackets 1 plus I to the power N, our deposit is 80,000, which earns an interest of 13% compounded monthly for the first 5 times 12 months, which is 60 months. 60 months. So with the 60 months, that means we are now at T5. So now at T5, the original amount we have just calculated acts as our new value of P for the next period of 3 years, when the interest is 17% compounded monthly. So 3 times 12 gives us 36. Gives us 36. That means now we are at T8. Then the whole value we have, the blue value and the black value, is the original or the P value for the next 2 years. So that means the whole of this here, the blue and the black, is our P, and after the P, according to the formula, use the bracket, and the bracket we have 1 plus the interest, which is 0.16. Remember, it decreased by 1%, divided by 12 to the power of 24. So you punch that in your calculator, and your calculator will definitely give you a value of 348,222, 14 rands. So that's how much the investment would be worth after the 10 years. So within the 10 years, there's been a change in the interest rate. So let's go to question number 3. Question number 3 talks about a school. Question number 3 talks about a school. A school buys a photocopying machine for 200,000. Calculate the scrap value of the machine after 10 years if the rate of depreciation is 14% per annum, calculated on the reducing balance scale. So, candidates, you need to know the formula for the reducing balance scale or the reducing balance method. It's A equals P brackets 1 minus I to the power of N. And what we have here, we have a machine that was bought at 200,000 initially, and it depreciated at a rate of 14%. This is over a period of 10 years. So you punch that into your calculator, you get 44,260 rands and 32 cents. So that means that after a period of 10 years, the school's photocopying machine has decreased to a value of 44,000, and the value of 44,000 is what we term as our the scrap value, or sometimes referred to as the book value, because this is the value that you record in your books. Okay, so let's go to another question. That's question number 4. Go to another question number 4. NOMC deposits 20,000 into an account at an interest rate of 9% per annum compounded quarterly. 3 years later, she deposits another amount of X rands. 2 years after that, the interest rate changes to 10% per annum compounded annually. She withdraws 12,000 at the time that the interest rate changes. At the end of 8 years, she has 43,062.25 rands in her account. Determine the value of X. X is the second deposit. So now here comes another situation where we have multiple transactions in an account. She deposits 20,000. 3 years later, X thousand. Then thereafter she withdraws 12,000. So we have 2 deposits and 1 withdrawal, and then the interest rate changes. First it was 9% per annum compounded quarterly, then it changes to 10% per annum compounded annually. So let's use our timeline to help us visualize what is actually happening. So draw the timeline at the top. At the beginning, T0, 20,000 rands is deposited into the account. 3 years later, so that means at T3, X amount is deposited. Whenever an amount is deposited into an account, that is a plus to the account. 2 years after that, the interest rate changes. So from T3, 2 years after, we find ourselves at T5. That is at T5. And at T5, that's when the interest rate is changing. So the interest rate is changing at T5. 2 years after that, the interest rate changes to 10% per annum compounded annually. She withdraws 12,000 at the time when the interest rate is changing. So at T5, there is a minus of 12,000 because every time you withdraw money from the account, you are subtracting. So it's a minus to the account. Then what else do we have? At the end of 8 years, so that means our timeline ends at T88. She has an amount of 43,062 rands and 25 cents. So what is happening here? Starting with the 20,000. This 20,000 is supposed to be into the account until the end of the 8 years. The X amount that was deposited should be into the account till the end. And the 12,000, if it was non-deposited, rather withdrawn, it would have been into the account till the end of the 8 years. So what happened? The interest rate changed, and it changed 2 times. First, for the first 5 years, the interest rate I was 9%, meaning 9 divided by 100, compounded quarterly, so you divide by 4. Then after that, it changes to 10% compounded annually. So meaning you divide by 1 because there's only 1 year in a year. So what is happening here? The 20,000 first of all grows at an interest rate of 9% quarterly for the first 5 years. Then thereafter, it grows at an interest rate of 10% for the next 3 years. So for the first 5 years, our N will actually be 5 times 4 quarters, which is 20. And then for the next 3 years, our N will just be 3 years. So let's first deal with the 20,000. First, the formula A equals P brackets 1 plus I to the power N. So the 20,000 earns the interest of 9% compounded quarterly for the first 20 quarters. Now we are at T5. After, the interest rate changes to 10% compounded annually, which means our N is 3 years. We are done with the 20,000. Next, let's tackle the X amount. That X amount was added to the account, so plus X amount. The X amount first of all earns interest of 9% compounded quarterly between T3 and T5. So that means it's for 2 times 4, which is 8 quarters. So this will be 1 plus 0,09 out of 4 to the power of 8. Now we are standing at T5. Then after T5, it earns interest of 10% compounded annually for the next 3 years. That is the X amount. But then the 12,000 was withdrawn from the account, which is a minus. Let me write it down here, minus the 12,000. But remember, every time you withdraw money from the account, you even lose the interest that money would have accumulated. So we have to treat the 12,000 together with the interest it would have accumulated as the amount lost into the account. So the 12,000 would have been in account for the next 3 years, where the interest is 10% per annum compounded annually. So, but then remember, at the end of the 8 years, all these 3 amounts, the first deposit, the second, and the withdrawal, the balance in the account, according to the question, was 42,062,27. So that means when we sum all the transactions on the right hand side, they should actually equal to our 43,062,27. So now you have to apply the algebra. But when you solve that, the value of x would actually be 11,000. Candidate, I trust that you are okay with algebra. But then if you're struggling algebraically, we shall have another session on algebra. But now let me take you through what you're supposed to do. Deal with values that do not have the x. For example, the 20,000 together with the two brackets, it gives you a numerical value. Then minus the 12,000 brackets 1 plus 0 comma 1 close brackets to the power 3, you get that value. Then subtract that value from the 43,062,23. Then after that, you divide by our red brackets. And then you end up getting your x value as 11,000, meaning that was the second deposit that Nomusa made. Question number 5. Determine how many years it would take an investment of 2,000 to earn an amount of 1,920 in interest. We are looking for the years. How many years? Meaning the value of n. If the investment was made at an interest rate of 13% per annum, compounded monthly. So it's compound interest. Don't forget the formula. Even if you don't know what to substitute, at least write the formula. Our investment was 2,000. 1 plus. The interest rate was 13% compounded monthly, so you divide by 12. Then we need our n, so 12 times n. But now what is the value of a? According to the equation, the 2,000 and interest is an additional amount, so it's 2,000 plus the interest of 1,920, and that gives you 3,920, and that is our value of a. That's what you're supposed to substitute on the left hand side. So 3,920. So first step, divide by the 2,000. So if you divide by the 2,000, you have 49 over 25 equal to, simplify what you have in the brackets. In other words, 1 plus 0,13 divided by 12, that gives you 1,213 divided by 1,200. But then remember, it's to the power of 12n. Our unknown is an exponent. So in order to find an exponent, we introduce the inverse of an exponent, which is a logarithm. So we are going to introduce log to the base of 1213 over 1200 on both sides. And once we do that, we shall end up with log to the base of 1213 over 1200 of 49 out of 25, and this should equal to 12n. So you punch that into your calculator, you end up with 62,4538 is equal to 12n. So actually now we have 62,4538 months. But the question is asking for years, meaning we need to divide our answer by 12. And when you divide by 12, that would mean your n would equal to 62,4538 divided by 12. This gives you 5,20. So therefore it will take 5,20 years, meaning it's 5 full years and some few months. And then lastly, about financial growth and decay is question number 6. Determine how many years it will take for the value of a car to depreciate to 25% of its original value. That statement is important. If the rate of depreciation based on the reducing balance method is 16% per annum, so you have to ask yourself, what is actually 25% of the original? This question, we don't even have the original value, which means we're going to use our variables. But the formula first, it's A equal to P brackets 1 minus I to the power N, because it's depreciation. The new amount, or the book value, or the scrap value, A, equals 25% of the original, and the original is always P. So the new will be 25%, meaning 0.25 of the original should equal to P brackets 1 minus 16% to the power N. We are looking for N. We are looking for N, the number of years. Of course, algebraically, the p's cancel. This leaves us with 0.25 on the left equal to. When you simplify the bracket, you get 0.4, actually 0.8, sorry about that, and 0.84, but then to the power of N. So now we are looking for the exponent, which means we introduce our logarithms again. So N would equal to log to the base of 0.84 of 0.25. Candidates, you punch that in your calculator and it will give you 7.955 years. Basically, this means that it is 9 full years, rather 7 full years with some months, almost maybe 11 months. But so this is how the questions are supposed to be approached. Remember, this is a stepping stone, so you need to check in all your past exam papers and look for questions, especially the section of financial mathematics, the first sub question, then you try to work out. Okay.